So in the next exercise, we will be looking at using the appropriate present value table, assuming 12% annual interest rate, the present value of these payments. Excuse me. So if we wanted to, here's how you could look at it, be able to receive $6,500 each year over a 5-year period, how much would we have to invest at time zero? So you're still looking at annuity payments, but you're not looking at what putting money away will be worth in the future. You're looking at, if I had this much today, how much would I have to put away today? And this way you could view it to get a certain amount over an equal amount over equal interval time. So we have some different scenarios. The first one is the first payment is received on December 31st, year one. So that's at the end of the compound period and compounded annually. The second scenario is the first payment is received on really January 1 of year one. So at time zero, you'll receive the first payment and you'll receive it at the beginning of each year. And then the next one is that you'll receive it at the end of year one and at the end of each year, but interest is actually being compounded quarterly on the money that's remaining. So the last problem dealt with what's the future value of these payments. This problem is dealing with what's it worth today. What would we have to invest today to be able to take that money out over that time period? So we're going to be calculating the present value of an annuity. Now we have to decide, is it an annuity due or an ordinary annuity? And that all depends on when those payments will be received. And the first one is being received at the very end of year one. So it means it's an ordinary annuity. So there'll be 5 payments, 12% interest at the end of each year. What are their present values? We will use the present value of an ordinary annuity table, 12%, 5 periods. 3.60478 is your factor. 6,500 times that. So what this is saying is, if you want to be able to take $6,500 out at the end of each year for the next 5 years, interest is compounded annually at a 12% interest rate, you would have to put away $23,431 on January 1 of year one, the very first day, present value right now, which is the same as December 31st of year zero. It's the same thing. Now in the second one, they said, okay, let's change this up. You're going to take the first payment out at the beginning of year one. So now you're taking the payment out basically at January 1, year 1, January 1 of year 2, January 1 of year 3, January 1 of year 4, and January 1 of year 5. Interest is still compounded annually, and you're taking out $6,500. How much do you have to put away today? Well, this would be considered an annuity due. So you would use your present value of an annuity due table. And I know I didn't use the calculator yet, but we'll use that in a sec. So 12% interest, 5 periods or 5 payments, $6,500 for 5 payments. You'll use a factor of 4.03735. So how much would you have to invest today in order to take those payments out? $26,243. So if you grab your finance calculator, get into your app, I'm going to get back into mine. N is 5, interest rate 12. We want to calculate the present value. Remember, with an annuity, you're either calculating present value or future value. The payment amount is $6,500. Future value is going to be 0 because we don't want to compute that. These payments are current. We'll start taking the money out at the beginning of each period. So we want to make sure the PMT word is highlighted with begin. Go back up using your arrow keys to the present value and solve. and you should get $26,243. Now in the last part, you're still taking $6,500 out, and it's going to happen at the end of each year because the first payment you'll take out is at the end of year one, but the interest is compounded quarterly. So we want to determine the present value of each one of these payments individually because of the way the interest is compounding. And there isn't 4 payments a year. If there was, we wouldn't need to worry about this. There's only one payment, but interest is compounding 4 times a year. So the first payment, because we're trying to find the present value, okay, the periods would be 4. From the first payment to present value, how many compounds will occur? 4. The second payment, back to the first, to time 0, would be 8 compounding. The third payment, so that's at the end of year 3, we want to go back to time 0, trying to get present value. So it reverses what it did for future value. And then we will use an interest rate of 3%. So we will use our present value of an ordinary annuity table, or I'm sorry, present value of 1. I'm sorry, not present value of an, that's right. In this case, we'll use present value of 1 because we're looking at each item. We're saying we want to take $6,500 out at the end of year 1. Interest compounds 4 times a year at 3%. How much should we put away today in order to do that? Same, we want to take $6,500 out at the end of year 2. How much should we put away today at time 0? So 8 periods from now. So we'll go 3%, 8 periods in the present value of 1 table. So you'll do that calculation for each of them using the present value. You've got to do them separately. Add them up. You should put $23,115 away. In exercise 611, now we're going to get into some scenarios here. Zelik recently won a lottery and has the option of receiving one of the 3 following prizes. $75,000 right now at time 0, today, present value. $22,000 today and a 7-period annuity of $10,000 a year beginning 1 year from today. So at the end of year 1 is when he starts receiving the $10,000. Now don't just go 10,000 times 7 is 70,000 plus 22. Woohoo, do that. No, because included in that $10,000 is interest. We want to know what are those payments worth today. And then the third scenario is a 6-period annuity of $17,000 beginning 1 year from today. Again, an ordinary annuity. Assuming an interest rate of 8%, which option should Zelix choose? And then we have a second scenario, so let's take a look. 75,000 cash today, 22, there's our scenarios. So present value of 75,000 is 75,000. But what about the second scenario? Well, 22,000 is at present value already. That's what it's worth today. But those $10,000 payments in the future, what are their present values as well? What is that money worth in terms of today? 10,000 times an ordinary annuity table. I forget what the interest rate was, and the time period would be the number of periods. Oh, there we go. So it was 8% interest for 7 periods. It gives us the factor of 5.20637. So that computation plus the 22,000. In scenario 2, the present value of that is really $74,064. So if you took item 2 today, that's all you would get. In item 3, you do the same kind of calculation. You're looking for the present value of the $17,000 8% interest for 6 periods because there's 6 payments. The payments start at the end of each period. So your factor is 17,000 times 4.62288. The present value of those are 78,589. So of the three, and this is how we compare scenarios, we got to get them in terms of a common dollar amount. What are they all worth today, or what are they all worth in the future? In this scenario, here's what they're all worth today. So it's item 3 you would actually make the most money on. The ER Corporation wants to accumulate a sum of money to repay certain debts due on December 31st of year 10. ER will make annual deposits of $6,000 into a special bank account at the end of each year for 10 years, beginning at the end of year 1. Assuming the bank account pays 8% compounded annually, what will be the fund balance after the last payment? Well, this is your classic future value of an ordinary annuity. You want to know how much will be there at the end of year 10. If you make your payments at the end of each year, so you're making 10 payments at the end of each year, 6,000, N equals 10, I equals 8%. So you use the future value of an ordinary annuity. You get a factor of 14.4866. Multiply it by 6,000. 86,920 is what they will have available to pay back that debt. Companies do this. They do it for bonds. Roseland Company purchased merchandise from Royal Corp on September 30th of year 1. Payment was made in the form of a non-interest-bearing note requiring Roseland to pay 6 annual payments of $4,400. Non-interest-bearing doesn't mean there's no interest. It just means it's not a stated rate of interest on the loan itself. We still need to figure out how much of that payment is interest. So, again, Roseland purchases merchandise September 30th of year 1. Payment was made in the form of a non-interest-bearing note requiring them to make 6 annual payments of $4,400 on each September 30th, but they don't start paying it until year 4, so there's more lag time. Calculate the amount at which Roseland should record the note payable and the inventory amount on September 30th. Assuming an interest rate of 12% is the proper interest rate to use. Whoa, we got some different stuff happening. So there's 2 major calculations here. The first thing we want to know is how much are these $4,400 in payments, these 6 $4,400 payments, what's the value of them really at time 0 today? We're trying to figure that out. But if you take a look, this isn't a classic annuity problem because there's no payments in the beginning. There's 3 years without no payments. So let's see how we tackle this. The first thing we do is determine what's the value of these 6 payments at the beginning of year 4. At the beginning, or the beginning of that year 4 period. Okay, so it would be like August, let me think a second. I'm going backwards here. It would be like October 1st of year 3. So the first thing we do, we have 6 payments of $4,400. Payment was made in the form of a non-interest-bearing note requiring Roseland to make 6 annual payments of $4,400. Present value of an ordinary annuity, 12% interest, N equals 6. So that's the first thing we want to find. But that's the present value of the annuity as of the end of September 30th of year 3. When is time 0? It's September 30th of year 1. So we still need to determine We know the value as of year 3. Well, what's the value of that at year 1? Now we present value it back 2 more periods, present value of 1. And when you see this, you'll use the present value table and you'll say, okay, the present value of the annuity on September 30th of year 3, which is really the future value of 1. We want to know if we're just earning interest between the end of year 1 and the end of year 3. What's the value? What's the present value? What is that worth? We need to pull out the interest component for 2 years, n equals 2 at 12% interest. So the value of this loan and the inventory that is being bought, the principal, $14,421. So that's what you would record the inventory at, and the note payable. So we use both more complex time value of money. Beehive Warehouses borrowed $100,455 from a bank and signed a note requiring 14 annual payments of $14,388 beginning 1 year from the date of the agreement. What is the interest rate in this agreement? All right. So the number of payments, the payments, times the factor, n equals 14, I equals who knows, equals the ordinary present value of the ordinary annuity amount. Well, we know the payment is $14,388. We don't know what the factor is. We need to determine that in order to find out the interest rate, kind of like what we did before with finding interest rate and periods of time. We know the present value of the ordinary annuity. Divide the payments into the present value of the ordinary annuity, and that will give you your factor. The rest is using the table. If you go to the present value of an ordinary annuity, n periods, 14 periods, go across until you reach 6.981, there it is, 11%. So not only can you have to find other variables with a single sum present value and future value, you may have to find other variables like interest rate or number of payments with annuities. Now, if you enter this into your calculator, you would go n equals 14. Interest would be blank for now. Present value is 100,455. Your payment is 14,388. Future value 0. Make sure the PMT is highlighted for end because it's an ordinary annuity. And then using your cursor, go back up to present value and solve. Nope, I'm sorry, I was wrong. I did it the wrong way. 100, we know our present value. Go up to interest rate and solve. Uh-oh, and I'm getting an error. You know why? Remember what I said about that negative sign. So we have to make either our present value or our payment a negative sign. So remember, it's on our new number pad. It's on the 0 and then the point, and then you have a negative number in parentheses. So I'm going to make my payment negative 14,388. Then I'm going to go up to the interest rate and solve. And I should get 11%. The final one we're going to look at is a bond, and this is classic present value calculations. On June 30th of year 1, Moonstone Computers issued 8% stated rate bonds with a face amount of $227. So let's just step back and make sure we understand what a bond is. When a company sells a bond, it's really borrowing money from whoever they sold the bond to. So they're issuing bonds that they promise to pay 8% interest. And they're going to pay it twice a year, it looks like. It says it right there, okay? And they're going to pay interest on 8% of the $227 million, which we call the face amount. They also promised to pay back the $227 million when the bond matures. The bond matures in 15 years. The market rate of interest for similar bonds is a little less, it's 7%. So with bonds, we have an issue. Companies develop bonds and decide to sell bonds a couple months before they even sell them. So they try to predict the interest rate that will be in the market at the time they decide to sell the bonds. This company thought it would be 8% when it actually came in at 7%. Now, people in the market are going to react to that interest rate difference. They're either going to pay more than $227 million or they're going to pay less. Whenever the market rate of interest, 7%, is less than the stated rate of interest, which is what the corporation promises to pay interest, 8%, the bonds sell for more than their face amount, because you can make more money purchasing these bonds than you would any other bond that day. Interest is paid semi-annually at 4% on June 30th and December 31st, and the first interest payment will be at the end of the first period, December 31st. We need to determine how much the bonds will sell for on June 30th of year one, the day we're selling them. You have two different present value computations. Again, the bond promises to pay 30 interest payments. 30 interest payments every 6 months, same exact dollar amount. 227 million times 4%. So every 6 months, the bondholder will receive $9,080,000. That's one computation. We will need to determine the present value of those payments. So what's the present value of the interest portion of the bond? The other thing that the corporation promises to pay is the face amount, the $227 million in 15 years. So one bulk payment at the end of 15 years. So we also need to figure out how much is that worth today? What's its present value? So you have two separate present value computations. No matter which one you're computing, your N is 30 and your I is 3.5%. Where did that come from? When we're computing present value on the bonds, we always use the market rate per compounding period. 7% annual interest rate twice a year. So we divide that by 2. It's 3.5% per compounding period. So we're going to do a present value of an ordinary annuity since the interest payments happen at the end of each compounding period. We're going to take the $9,080,000 times the factor for 3.5%, 30 periods. And that will be, so the present value of just the interest that will be paid to the bondholder, $166,999,814. Then we're going to find the present value of the face amount. Bondholder, you give us money today, we'll give you $227 million in 15 years. We're going to use $227,000. We're going to find the factor for N equals 30, I equals 3.5%, because that's the compounding periods. So the present value of the principal or the face amount of the bond is $80,875,560. So the selling price of the bond, it will be those two added together, the present value of the interest portion of the bond and the present value of the face amount of the bond. So what is a person willing to buy the bond for, and what should the company sell the bond for? $247,875,374. And you can see that is a lot more than $227 million. Bonds usually need their selling price computed doing this kind of calculation. Back when you learned about bonds in Accounting 112, they just said they sold at 98 or they sold at 102. Well, this is how they come up with those 98s and 102s. It's the present value. We always use the number of compounding periods for our interest, so the number of interest payments, and our I is always the market rate and how many times it compounds per year for both calculations. Okay. And then the second part said, okay, what is the interest expense for the first year? Well, to determine interest expense, and this is something just a little bit beyond the scope of our chapter, we take the selling price or the carrying value of the bonds for the first year times the market rate of interest, that 3.5%. And that's how much our interest expense will be. You don't have to worry about that for a test or anything, but I just wanted to show you that. Okay, so those are examples. We started out very simple with just the basic calculation of present value, future value of one, present value and future value of an annuity, and then we got into the more complex calculations and where we really use these present value and future value calculations in finance and accounting. So if you have any questions, please post them to the discussion board.